Okay, so we see our solution to problem 4. For that function, what value of k will the function have? No zeros, 1 0, 2 zeros. Okay, I'm going to put the blinders on a little bit. Let me just say I do that. And maybe I just examine the first instance. So I'll do that one in blue. What values of k make that have no zeros? Well, I know that if it has no zeros, and zeros are another name for a root or a solution or so on, then that tells me that my discriminant must be negative. So now I can just go through and I can solve for that situation. Well, the first thing I'm just going to highlight in my problem, and I'll do that in gold. There is my entire a value, because k plus 1 represents the coefficient on x squared. There is my entire b value. There's my coefficient on my single x. And there is my entire c value. There's my k minus 1. So for me to use my discriminants, that would tell me then that, and I'm going to put the solution still in blue, that my b value squared minus 4 times my a value times my c value must be less than 0. Okay, we get to that instance, and now mechanics should take over. We should be looking to simplify everything. So let's square the first term. Now I expand those brackets, and I notice I have conjugates. So when I expand, that's going to give me a difference of squares. And now we actually get to this point where I notice my k squared terms cancel out, and I get that as my statement. Okay, that was all mechanics after my first line. So my first line that started, there's my problem solving. The rest just became mechanics. And I get down to 4 is less than 0, and we should be scratching our heads right now. Now, to some extent, we might be doing that because we don't really know where to go. I'm going to argue to you, you're almost done. All we need to do is draw a conclusion. Take a look at that last line. Under the context that I just starred, in order for b squared minus 4ac to be less than 0, we create this situation where it says 4 is less than 0. Now, when we read 4 is less than 0, we should be scratching our heads. Because 4 is less than 0 is not a true statement. So, in order for the condition that we set to exist, something untrue has to happen. 4 has to be less than 0, and that is not possible. And therefore, we get no solution to the inequality we created. Now, we have to be good. Okay, well, what does that no solution mean then? How do we interpret it? Well, the way I interpret it then is my original setup must not be possible. That means that b squared minus 4ac cannot be less than 0. And if less than 0 meant that there was no zeros or no roots, then that tells me that it's impossible for that equation to have no roots. That means I can always solve it. So under what conditions or for what values of k will the function have no zeros? It is not possible. So now we're starting to look at it and say, okay, maybe I progress to like the next one. Can we just make sure that we also then draw the conclusion, when does it have 1 0 or when does it have 2 zeros? Potentially, those both will always exist. No zeros can't. So therefore, there must always be at least one solution. So that's what I can draw my conclusion from that blue solution. I was trying for no zeros, can never happen, so I know that there has to at least be one solution. Could be two, but at least one. Okay, now I'm going to jump to the next scenario. Well, that next scenario is my 1, 0, and I'm going to do that one in gold. So I'm going to erase my 1, 0 now, and I'm going to nail in gold, 1, 0. Well, I don't have to do all that work all over again. Because notice, this whole left side is my discriminant. Just simplified. So I can get rid of all those underlines, and I could come in right away and say, for my 1, 0, my gold solution, 4 must equal 0. Well, we should be scratching our heads on that one, but maybe just a little less, given what we talked about in the blue. Can 4 ever equal 0? No. So that means that there's no solution to that equation that we just created. It's not possible. So now no zeros is impossible, 1, 0 is impossible. That allows me to draw the conclusion that there must always be at least 2 solutions. Okay, now I need to jump into the last one, and I'm going to tackle that last one in purple. So I'm going to erase that underline, and now I'm examining the 2 zeros in purple. Well, for me to get 2 zeros, then I know my discriminant has to be positive, so therefore 4 must be greater than 0. And that we should love to see. We might still be scratching our head a little bit, but a lot less than the previous two. When does 4 become greater than 0? When is 4 greater than 0? That's an always. That's always true. 4 is always bigger than 0. So what conclusion can we draw there? I'm just going to shrink this down a little bit to get a little bit more room. Here's the meat of the problem. When is 4 greater than 0? Always. That means it doesn't matter the value of k. So what that means, therefore, k can be any real number. The function f of x, that f of x always has 2 solutions. Always. There we go. So I'm hoping as you worked your way through 4 felt like you had to stumble a fair amount. Maybe you didn't tackle it that way. You might have examined just your discriminant alone and then looked at the 3 separate. It probably didn't take a format like the way I presented my solution. There was nothing pre-designed in my mind about how I presented that solution. But I'm hoping it afforded us the opportunity to kind of stumble and see how our discriminant can be super useful when dealing with maybe some quirky functions. Okay, I'm hoping that problem gave you a good experience, and hopefully we kind of found our way down to the same point, the same idea. Okay, if we were able to, great work. If we stumbled our way through this thing over and over and over again, and we gave it a bunch of tries, and it didn't check out, great work. The whole point was the experience. Okay, I'm hoping your practice is going well. Good job.